We are going to study how to find standard deviation for ungrouped data. And the example is find standard deviation using data. Data is 2. First observation in the data is 2. Second observation is 3. Third observation is 5. Fourth observation is 4. And last observation is 1. So the solution start with the line find standard deviation. Standard deviation is denoted by using notation S dot D and sigma. And on the next line, we write formula to find standard deviation. Standard deviation is equal to S dot D sigma is equal to root of variance. But the value of variance is not given in above example, and therefore this is our statement number 1 because variance is unknown number. On the next line, we find variance, but variance is obtained using two formula, and to choose appropriate formula to find variance, here we check our data first. In our data, the first number is 2, second number is 3, third number is 5, second last number is 4, and last number is 1. That is, here we have given single values in the data. And when we have given single values in the data, then this data is called as ungrouped data. And for ungrouped data, variance is obtained using formula. Variance is equal to sigma square. Sigma square is the notation to define variance. And formula to find variance is summation x of I square upon n minus x bar square. To use this formula, here we require two numbers, x bar and summation x of I square. But both numbers are unknown because the values of x bar and the value of summation x of I square is not given in above example. Therefore, these two are unknown number, and that's why this is our statement number 2. So for statement number 2, we first find x bar, unknown number. On the next line, using formula, x bar is equal to summation x of I upon n. Why we choose this formula? Because given data is ungrouped data, and here to use this formula we want summation x of I, the value of summation x of I. Again, the value of summation x of I is not given in our example, and therefore summation x of I is unknown number, and that's why this is our statement number 3. Here x of i's are the observation, that is our original data, and n is total number of observation. Total number of observations are obtained by counting all values in the data or counting numbers in the data. So when we count all values or all numbers in the data, then we get n is equal to 5. For statement number 3, we want summation x of I, and in statement number 2, we want summation x of I square. To find summation x of I and summation x of I square, on the next line we make a table. Table contains two columns. First column is of x of I. X of i's are the observation, that is our original data, 2, 3, 5, 4 and 1. And second column in the table is of x of I square. X of I square is obtained by squaring all values of previous column. So the first value 4 is obtained by by taking first value of previous column 2, squaring 2 we get 4, then by taking square of 3 we get 9, taking square of 5 we get 25 in second column. Similarly, 16 is 4 square and 1 is 1 square. Addition of all values of column 1, that is x of I, is denoted by using notation summation x of I, and summation x of I is equal to 15. When we add all values of column 2, that is 4 plus 9 plus 25 plus 16 plus 1, then we get summation x of I square, and summation x of I square is equal to 55. After this, we use three statements, previous three statements one by one, but from bottom to top, and that's why we use for statement number 3. It is of x bar. X bar is equal to summation x of I upon n. Here summation x of I is 15 divided by n is 5. 15 divided by 5 is equal to 3. Then we use statement number 2. It is of variance. Variance is equal to sigma square, and sigma square is equal to summation x of I square, 55 upon n, 5 minus x bar raised to 2, 3 raised to 2, because your x bar is 3. Solving this, we get sigma square is equal to 55 upon 5 is 11, minus 3 square is 9, 11 minus 9 is equal to 2. Then use statement number 1. It is of standard deviation. Standard deviation is denoted by using two notations, s dot d and sigma, and is equal to root of variance. Root of variance is equal to root of 2 because the value of variance is 2 here. That's why we write root 2, and the value of root 2 is equal to 1.4142. This value is obtained using scientific calculator.